6.2 Revolutions by Maggie Tran. So what is a revolution? For example, we have this linear graph and we're going to revolve about the y-axis. As you can see, each revolution is a cylinder. So to solve for this, we have to have a equals pi r squared. This will be applied in a few moments. So there are three different types of functions we use for solving volumes of revolution, but it's all summed up by v equals integral from a to b ax dx. So the disk function, v equals pi times integral from a to b of r squared dx. Then our washer function, v equals pi times integral of a to b of big R squared minus little r squared dx. Then the last one, the shifted washer, which is v equals pi times integral from a to b times big R minus number squared minus little r minus number squared dx. So the disk function is used for when we have one function, the washer function is for when we have two functions, and the shifted washer is for when we have to revolve about x equals a number or y equals a number. For example, we have to revolve about x equals 2 or y equals 4. So some common mistakes people usually do are when people put pi in front of everything even though they're doing cross sections. Pi is because our base of the cylinders revolving about the x-axis is a circle. Another common mistake people make is that they forget to square the washer or the shifted washer. One last common mistake people usually make for when we're using the shifted washer function is that when we're revolving about x equals a number, we forget to change big R and little r into terms of y. So let's try a practice problem. F of x equals x squared. So that's my sketch of the function and how we're going to revolve about the x-axis. So the area of a cylinder is a equals pi r squared, and then this is how we apply it to the the disk function. And so it would be a equals pi times integral from 0 to 2 x squared dx. And if you solve it out using the fundamental theorem of calculus, you get 32 pi over 5. So for this next one, we're going to be revolving the bounded region. And for this one, we could use the washer, but it's better just to use the disk function. So we get 2 minus 1/2 x squared. If you simplify it out and you find the antiderivative and then solve by using the fundamental theorem of calculus, your answer should be 19 over 12 pi. So for our next problem, y equals x squared and y equals square root of x. And that's my graph. So for this one, we're going to be using the washer function because there are two functions. And so we have v equals pi integral from 0 to 1 square root x squared minus x squared dx. So if you solve this out using the fundamental theorem of calculus, you get v equals 2 pi over 5. So the big R is the upper function and the little r is the lower function. Using a graph helps and see which one is the upper and lower function, or we can just plug in x into the y functions and see which term is higher than the other. So for this problem, we're going to be revolving the bounded region. So for this problem, we're going to be using the washer function because the upper function is 1 over x and the lower function is y equals 0. So to solve it out, we have to find the antiderivative, which is just negative 1 over x, and then we use the fundamental theorem of calculus to solve it, and your answer should be positive 3 pi over 4. I don't know why I wrote negative, but yeah. So for this next problem, we'll be revolving about y equals 4 and finding the volume between the bounded region. So big R is y equals 0 and little r is y equals x. So we have v equals pi from 0 to 3. 3 is found by the point of intersection of y equals x and x equals 3. So if you plug in into the shifted washer function, you get that. And you simplify it out, you get the 16s cancel out, and then you find the antiderivative of that and use the fundamental theorem of calculus to solve it out. And then your answer should be equals 27 pi. So once again, for this one, we obviously use the shifted washer, which is that equation. So for this problem, we'll be finding the volume between the bounded region and about x equals 10. So this one we'll have to use the shifted washer once again, which is v equals pi times integral from 0 to 6, and 6 is just the point of intersection. And big R would have to be y equals 3x, and little r has to be y equals 1/2 x, because it's the farthest or closest away from the x equals 10. And if you plug it into the shifted washer, you get that equals pi times integral from 0 to 6 times 10 minus x over 3 squared minus 10 minus 2y squared dy. For this one, we're only going to be doing the setup, but it's really important to change y equals 3x and y equals 1/2 x into terms of y. Thanks for watching. I hope you found this video helpful.